All right. Hi, everyone. Welcome. Welcome to Vegas. Welcome to the session. 5:30 Mandalay Bay, you guys must love us. All right, today we're going to take you through this journey of what's new with Amazon EBS. We're going to cover the innovations we have done in the past 12 to 18 months, and we're going to have a little bit of fun. So my name is Aaron Chen. I'm a product manager at Amazon EBS. Along with me is my friend Suraj Prasannan. He's also a product manager at EBS. We'll invite him down the stage, and I'll walk you through the first half of the journey, and then we'll swap. Cool. So before we get started, let's talk about EBS a little bit. EBS stands for Elastic Block Store. At its most basic, it's a network-attached persistent storage to your EC2 instance. The storage is connected to your virtual machines over the network, so it's disaggregated from your EC2 instance in terms of the data lifecycle. You're able to stop and restart your instance. You're able to reboot your instance. Your volume and your data is still going to be there, right? That's why we're able to offer the different volume types because it's attached over the network. You have your IO2 for mission-critical workloads. You have your GP3 for general-purpose workloads. EBS also provides the capability of backing up your data by snapshotting. Snapshots is backed by Amazon S3 to provide high durability. So in case of an issue, you are able to start from your snapshot and go back to your production environment. And the last part, between volumes and snapshots, you want to move data. This can help you with the different workloads, such as instant boot, test and dev environment creation, or disaster recovery. That's what we call data service. So EBS consists of those three pillars. One thing that's very important to know is that EBS is not just a provisioned disk. It's just not only offering the block storage volume, but behind the scene, it's actually a vast distributed system. And it's maintained and operated by our EBS engineers. So it's with that kind of system, we are able to offer you different levels of performance, durability, and different features. So in terms of workload, EBS is a storage that serves a variety of workloads, all the way varies from most mission-critical workloads that's powering your ERP and the CRM, to all the boot volumes that booting your EC2 instance, or to the indexing layer and the caching for your analytical reporting environments. If you have ever spin up an EC2 instance or ever run anything on Amazon Web Service, chances are you have used EBS. So like all the Amazon services, all the innovation we do are deeply rooted in the customer needs and use cases. EBS is no exception. So today, we're looking at the EBS innovations through the lens of a customer. Let's use this rapidly growing fintech company as an example. They have their core business as an operating database for their real-time transactional processing. They also have an analytical warehouse, so they can use that to understand what's happening with their business, with daily and weekly reports, generating insights, trying to analyze their business, etc. Lastly, to provide the new features and the new experience to their customers, they need to build and test. And that's why they have a developer environment, so they are able to continually bring more innovations to their customers in a more controlled environment. So we're going to talk about our innovations in these three aspects. Let's start with the transactional processing systems. So these are your most mission-critical applications handling their incoming customer traffic. For our fintech customer here, their customer experience is directly correlated to the performance that's underlying the system, which is why their business is critical. These applications are typically backed by relational databases, and those relational databases run on EC2 as your compute layer, while the EBS as the persistent storage layer. These relational databases usually require a consistent sub-millisecond latency. This is because that the application will trigger multiple combined IOs, and when they come together, the storage requirement is taking multiple transactions or millions of transactions. In addition, because they wanted to rapidly grow and expand globally, they will need the infrastructure level parity worldwide. That they can simplify their infrastructure, they're able to run their applications without any modifications with the same architecture everywhere. It takes a lot of operation burden off them. Lastly, because of this system is very mission critical, the customer needs to constantly ensure that their system is of high resiliency. As a result, they need observability to understand the performance of their systems if it's meeting their expectation. And they need to continue to test if the system's resiliency is good enough and if the failover mechanism will operate as expected to maintain the high availability. So let's unpack all three, each of them. Let's start with the performance metric, which is the millions of transactions or consistent sub-millisecond latency. So to deliver the desired experience where customers don't experience a lag when they run something, these applications require to have a storage layer that is very low latency. Imagine you are clicking a button, you're submitting a form, you're making a purchase. These things usually will trigger a ton of correlated IOs that's either read or write. And all of us would hate that spinning circles and waiting for something to process. So to ensure the customer getting the instant response on these things, each of the storage IO needs to have a very low latency, ideally sub-millisecond. And to ensure that experience is actually very consistent, your storage layer needs to deliver a sub-millisecond latency or very low latency in a very consistent manner. If you don't, they might lead to lag or even the application unavailability. And then it could lead to loss of sales or loss of revenue. So there's also real monetary impact. So that's why, as EBS, we recommend you to run the very critical workload on IO2 volume. IO2 volume provides the best, lowest P99.9 IO latency among the major cloud providers. And we further tightened our latency guidance from the sub-millisecond average latency to sub-500 microseconds. Beyond that, we also added clarity to how our IO2 outlier latency differentiate from our general purpose volumes. So now customers are able to understand the difference and making the right price-performance trade-off. So we cover the performance. The next pillar is the global infrastructure parity. So as our fintech company grow more into different places, you also wanted to develop in those new regions that are different in the worldwide. So you want the same infrastructure available across the regions. It will reduce the operation burdens and will bring the data closer to you, to their customers, in this case, so they can achieve lower latency and offer the same experience everywhere. As a result, we expanded IO2 Block Express volume to all commercial and gov cloud regions, meeting the customer needs. So our fintech company here is able to serve their customer in the same way everywhere. Now we talk about the performance. We talk about global parity. The next pillar is high resiliency. For application to be high resiliency, it starts with one thing, and that's measurement. A lot of time that we hear customer asking us this question is like, I have an EC2 EBS environment. How do I monitor the performance? Do I have enough headroom? We just got an issue. Is it an application issue or an infrastructure issue, and AWS can help? So with these, you actually want to provide observability. And observability have helped customers to understand their performance and to understand where things can go wrong. So over the past couple of years, EBS has been on a journey to improve the visibility into the volume performance. In 2024, we launched a metric that is average latency in CloudWatch. This provides customer to be able to understand where is the performance bottleneck. This year, we launched IOPS and the throughput metrics in CloudWatch so that now customer can monitor and track performance trend and optimize. These are the regular metrics. We also launched another set of metrics called exceed checks. So last year, we launched the volume level exceed checks, and this year we launched the instance level exceed checks. These exceed checks are the zeros or ones metric that if your driven IOPS or throughput reach beyond your system's entitlement, it will turn into 1, and you know that's where your bottleneck is. Right? With those signals, it tells you right away that the performance degradation is because of the entitlement of your system or something else. Right? So with that, if your bottleneck is on the volume side, you're able to use the elastic volume to tune up the performance and to release that. Or you can modify the instance size. So now customers say, I can measure the impact. What's next? I can see the average latency, but how do I know that at what time my system will get disrupted? And if my standard operating procedure will work? So introducing chaos testing, right? It's not an unfamiliar concept because it is necessary today to build a resilient and reliable system by proactively providing tests and finding those vulnerabilities, and then you can fix them. So chaos testing is something that you've done in a controlled environment because you don't really want to do it on your production. So when you do that, you intentionally simulate a failure in this environment so you can uncover the hidden weakness or dependencies. And once you realize that, you can fine-tune the process to improve the recovery times and to test your standing operating procedures to ensure the system fail over to the other side correctly. And that is very critical for the modern complex and distributed systems. So AWS fault injection systems or FIS, fault injection service or FSS, is the service just for that. It is a managed service that enables you to run these fault injection experiments on your workloads. If you think about EBS faults, it manifests itself as a slow I/O or stuck I/O usually. And in 2023, we've launched a EBS action in FIS called stuck I/O. So you were able to test if a volume was stuck and monitor if the timeouts and alarm functions are working as expected. Well, this year we are introducing more tests in your latency. So you're now allowed to inject latency to your system. So think of it as you're simulating a grave failure. Right? So we offer 4 different types of templates so you can run the tests, such as the sustained latency, increasing latency, or intermittent latency as like your spike, and then your decreasing latency. Of course, you can also specify and build your own custom template by inputting the read and write mix and introducing latency to read or write. So with the performance tested and observed, with the impact on mitigated on the standing operating procedure, the other part of the protection to achieve resiliency is to prevent data loss. Customers sometimes delete volumes by accident or even malicious intent. And that is very important because those kind of disruptions can result in financial loss or sometimes even damage to your reputation. So having such a data protection strategy is critical, and ensuring the data can be restored in a timely manner after incidents is very important. We've launched Recycle Bin for EBS snapshots a couple of years back, And now this year, we have extended that support to EBS volumes. To use recycle bin, you are able to set a retention period. So when you delete a volume, your volume goes right to the bin. Within the retention time, you are able to perform a recovery action, so the volume goes back to production. Those recovered volume is immediately available, and you're able to attach it to your EC2 instance and resume your workloads. The volume will retain all the tags, all the encryption status, or permissions that you specified for it before. For the volumes that are not recovered and the retention period elapsed, then they are deleted permanently when the retention period expires. So you can create these retention rules by a single volume or by group volume. Just use tags and to figure out. Okay, now coming back to our fintech customer. I can't hear you clearly, I'm sorry.
Is that like a snapshot protection?
Yeah, it's the same thing as the we launched for Snapshot. So coming back to our fintech customer here, we covered the first pillar, which is the real-time transaction system. Now let's welcome Suraj back to the stage. He'll talk to you through about the other two. Right.
Thanks, Aaron. So Aaron spoke about the real-time transactional systems, which are extremely important to run your business, right? But if you think about the analytical warehouse system, that's where you get to figure out, hey, what's happening with the business? Where is the business going? And what do you do about it? So it's extremely important. In a way, I think about it as you have so many different stakeholders in the business. It aligns everyone on a single source of truth, right? So that's why your analytical warehouses are so important. And if you think about some of the questions you would ask from analytical systems, if you think about financial data, it would be, how are my margins trending? How is my revenue trending? If you're thinking about sales question, you would be thinking about, how are my products selling in each of the different regions? If you're thinking about marketing, hey, you're running different kind of campaigns, right? And you want to know how is the conversion for some of these campaigns, and if something is going great, how do you double down? If you are doing product development, you're trying to figure out, how are my customers using my product currently? What is the sentiment? What are the complaints you're hearing? So you can drive that to drive better product decisions. And on the inventory side, you're trying to figure out, hey, do I have the inventory to support my customers? So there are different kind of questions you want to ask from the analytical warehouse system. As you would imagine, it has a bunch of data which streams into these systems. And then you have to run analytics and querying on it to get the insights. So it's a very resource intensive system, and we'll get into what kind of product storage requirement it drives and what we have done in 2025 to make the analytical warehouse system much better to run on EBS. So as I said, you have all kinds of data streaming into the analytical warehouse systems, and typically the storage is S3, right? So you have your OLTP system streaming data through your change tracking into the systems. You have your sales data, finance data, marketing data, IoT data. Like, think about all the kinds of data which is streaming into S3. And for that data, you would think it's going to be in all different kinds of formats, right? So if you have to run a query, you have to normalize it to some extent so you can run queries on it. So that's where one place where EBS comes into play, when you have to do the ETL jobs on these huge data sets, which is reside in S3 because you need a faster processing layer. The other place where EBS comes into play is when you're running queries. It could be your nightly queries, it could be ad hoc queries, it could be your nightly reporting jobs. Customers need a fast storage layer there to kind of speed up those queries, right? So the first requirement is data has to be extracted quickly from S3 into the EBS layer so you can run the ETL jobs or you can run your queries. The second requirement is, if you think about these queries, if you're thinking about aggregates and joins, there's a lot of data, intermediate data, which gets generated, which you necessarily don't want to persist in S3, right? It's a throwaway data, which you don't want to keep long term, but you want it absolutely during the time when the query is running. So because if you lose that data or if the volume fails, then you'll have to rerun the whole query again, right? So it's important that EBS has enough capacity to manage that query layer. And lastly, if you guys are aware of how these data processing layers work, typically there is a Spark framework. So they take a query job and they split it into smaller jobs. That's one way to think about it. And then you make sure that these jobs they split it into smaller sections so they can run in parallel, and also it's better failure management. So if a small job fails, you have another job which comes up, spins up in its place, another EBS volume attaches, and it goes, right? And customers typically use containerized environments for that kind of processing. So now if you take a step back, we need high throughput, we need large capacity. Now you can definitely get that by combining, raiding different kind of EBS volumes. That's one way to do it. But the hard part is in containers environments, RAID is not natively supported. I mean, RAID in general is cumbersome, but in containers, if you're dealing with a lot of systems, it's going to be extremely hard to support raiding of volumes. So that drives the requirement that, hey, from a single data volume, I need very high throughput and very large capacity. Right? So that's what motivated us to deliver GP3 volumes with larger performance and higher, larger size. It reduces the need for you to RAID volumes in a containerized environment. So we increased IOPS by 5x. We went from 16K to 80K. Throughput doubled it from 1 GB to 2 GB throughput. And we also increased the size from 16 terabyte to 64 terabyte, so 4x improvement in size. So Aaron also spoke about the OLTP system. So this also helps in your OLTP environment. So typically what customers do is they have a production environment which might be running on IO2 BX volumes for latency consistency. But then your test dev environments don't need that kind of performance, so they will be running on GP3. But they need the same size, right? So if you have a 64 terabyte IO2 BX volume, before this launch, you would be striping 4 GP3 volumes to get that same test dev environment, and it's very cumbersome if you're snapshotting that environment. So now with this launch, you can have a 64 terabyte IO2 volume and a 64 terabyte GP3 volume, so simplifies your test dev workflows, so improves developer agility. So that was one of the features we launched for the analytical workflows, also helps OLTP. Now, as you know, EBS is network attached storage, just having a very large volume with a lot of performance. Investing just there is not going to solve the problem. You also need to make sure that the network pipe, which comes from the compute to the EBS fleet, is big enough that customers can drive that throughput, right? Drive that performance to the volume. And this has been a journey for us because bigger the pipe, the lower the TCO, total cost of ownership of an EBS solution. Customers who have very large scale-up workloads also helps them land like even larger and larger workloads on top of us. So we started with 100 IOPS, sharing with EC2 networking back in the day. With Nitro enabled, all the Nitro instances have a dedicated EBS pipe with much larger performance. In 2019, 2020, we realized that customers need a separate SKU with very high networking performance. So we launched R5B, also R5N. So R5B had 3x higher performance than the generic instances at that point in time. Then we launched R6IN to follow that up. And this year we launched R8 GB. It has 150 Gbps of bandwidth. So that's 18.75 gigabytes of throughput from a single instance to the EBS fleet, and 720K IOPS. Right? So with that, if you have an OLTP system, as Aaron mentioned, they are very latency sensitive. They're very tightly coupled systems to deliver that latency sensitivity. Right? So that requires scale-up kind of compute, right, if you think about it. So a lot of CPU, a lot of memory, and as a result, a lot of storage performance needed from a single instance. So it helps with that for sure. You can land like even larger and larger workloads on AWS and on EBS. The second thing, as I said, if you in the previous slide, these query jobs get broken down into smaller jobs. So when you're running these analytical jobs, you're using smaller instances. And generally, when you're using instances, you don't want your CPU or memory to be stranded, right? That's the most expensive part of an instance. So by making the pipe bigger, we ensure that that doesn't become the bottleneck, right? So you have better TCO of running an EBS solution. So that was for the analytical workflows, helps OLTP as well. We use that as an example because it's easier to explain in the analytical framework. Now the next thing and the last one we want to discuss is the developer environment, right? So if you think about a developer environment, the customer has a production environment which is taking live traffic. They want test dev environments for development purposes, but the requirements are the production environment should not be impacted when you're creating a test dev environment. You also want to make sure that the data you're transferring to the test environment is not sensitive, right? You don't want that data to be widely shared. So those are the two requirements on the production system when you're trying to create a copy of your volume. And then the other workflow and the other requirement on the test environment is they want the data to mimic production environment. So there's this push and pull from both sides because you want similar-ish data so you can work on that. You can simulate real-world examples. right? So if you are a person managing infrastructure for developers, there are a couple of things you want to think about. You want to ensure that the test environment is as close to the prod environment as possible. And if you have a distributed development team, you want everybody to work off the same code base, right? So those are the two things. So think about our fintech customer. They have a real-time transaction system, live traffic. There's an issue. They want the ability to create a copy of that environment as quickly as possible, debug the issue, root cause the issue, fix the issue, and deploy the fix, right? So we'll see how we made the developer experience simpler this year with the features we have launched. So digging deeper into both of those workflows. So the first workflow is a copy workflow. So you have a production environment with EC2 instances with a bunch of EBS volumes attached. You create your test dev environment, again, instances with a lot of volumes attached, right? So in the prod environment, you don't want any kind of impact when you're creating these copy workflows. You don't want to copy sensitive data as well. So that's a requirement on the prod side. On the test dev side, you want to create more frequent copies of the data so it's as fresh to the production environment as it can be, right? So you want to be very close to that. The other requirement is on the production side, you might have volumes. You might use IO2BX volumes, right? And on the test dev side, you might not need IO2BX because it's not very latency sensitive. It doesn't make sense to have IO2BX there. So you might want the ability to mix and match volume types. Your source could be IO2, your destination could be GP3. So those are the requirements which that workflow drives. And then if you think about the second workflow, which is, hey, I want all my developers, like this fintech company which we're talking about is growing globally, right? So they have developers all around the globe. They want to make sure everybody is working off the same code base. So in that case, what customers do is they create an army, which is Amazon Machine Image, a golden army, which basically underneath the covers is creating snapshots, right? Army creates snapshots, and then they copy the army across different regions. And copying the army triggers copy snapshots underneath the covers. And then when you create a dev environment, you are launching an instance from an army, right? So again, that's a volume getting created from a snapshot. So you can see there are multiple moving parts here. Customers triggers this workflow, sometimes daily, sometimes weekly, based on their development cycle. So for both of these workflows, they require predictability and speed, because if it's not predictable and fast, it's very cumbersome to manage, right? So that's what we heard consistently from our customers. So let's look at what we did in each one of them. So we launched EBS volume clones this year. So previously, customers, when they had to create a volume clone, they would use snapshot as the intermediate layer, right? You would create, in our fintech environment, they would have IO2BX volumes. They would create a snapshot of those IO2BX volumes, which means pushing data from the EBS volume, the EBS fleet, to EBS snapshots, which is on S3. Then you're creating a volume from that snapshot, which means, again, pulling down data from the snapshot down to the EBS volume, right? So it takes time to do that. It's cumbersome to do that. And then after the data is fully, after the volume is fully initialized, you would attach those volumes to your test dev environment and your instances to trigger the test dev workflows. With volume clones, what we have done is we have taken the snapshot out of the picture. So now you copy data directly from the EBS source volume to the target volume. It's a single API call, right? And you can create a performant volume with a single API call instantly. You can start with an IO2BX volume on the left-hand side, create a GP3 volume on the right-hand side for your test dev environment. And we make sure that the prod environment, the prod data, prod volume does not get any kind of performance impact, right? So those were the requirements from the previous slide, so you have done that. So as I said, the previous workflow used to be, say you're a developer managing the previous workflow. You had to know when the snapshot was completed. You have to know when the volume is fully initialized. That's very cumbersome. With this, we have improved developer efficiency. And if you recall, the other requirement was to create copies more frequently, right? Now that copies doesn't take a lot of time to create, you can create more copies frequently to keep your test environment as close as possible to the production environment, which improves the quality of your code, right? So that's what we did. Other than this workflow, we also see customers use cloning, and this was an emergent use case. I think we kind of knew it could be used for blue-green deployments. So blue-green deployments are where customers would have two live environments. So there's a blue environment, which is the existing code base, and they have a green environment, which is the new code base. And over a period of time, they start moving traffic over. And if everything goes fine, they switch over, and the green environment becomes the new environment. And if something goes wrong, they can quickly flip back to the blue environment. So it reduces the risk when you're deploying software, also makes it much more seamless. So previously, customers used to use snapshots for that. So you can imagine if you're using snapshot, as I said, it takes more time. So as a developer, you're managing the blue and the green the deployments with green environments for a much longer time, right? Because you have both of those things going at the same time. Now with copy, you can just have the new environment created. You still have to manage the flip over and all that. That's still on you. But still is much easier and much simpler to do than before, right? So it minimizes, you can switch, minimizes the developer environment and improves developer agility, which was one of the main motivations for doing this. So that's volumes clones. The other workflow was the golden image, which you had, and you want it to copy it across regions to developers all across the world, right? And as I said, there are multiple steps in that workflow. One of the things you have to do is you create an army, then you copy the army across different regions, and then you create volumes from it. You don't want, like if a developer is coming online in the morning, you don't want the developer to deal with a system which is not fully performant, right? That's waste of their time and waste of resources. So that's one constant feedback we heard. So copy army workflow by design is the best effort workflow. So if you're copying an army across different regions, based on how busy the regions are, your speeds will vary, right? So a developer in Dub region would get something faster versus a developer in FRA region, for example, EU West and EU West 2. I use the internal names. So we launched time-based army copy last year in February. So you can give us a time as low as 15 minutes, and we'll make sure that across all regions, these armies get copied in 15 minutes, right? So that makes it much easier. It's predictable that you know the armies are going to be there. The other part of the workflow is launching an instance from an army, and that triggers pulling data from the snapshot to the EBS volume, right? So that workflow is also not predictable. It's best effort based on EBS snapshot, how heavy the load is on the snapshot, on the S3 fleet, and on the EBS volume fleet. So here again, we launched provision rate for volume initialization. You can go up to 300 megs. We ensure that the data gets pulled down from S3 at that speed, right? So you know predictably when the volume will be fully ready, and you can give that to your developer, and he can be sure that the volume is fully performant. Along with that, we also launched the ability to know that, hey, all the data from the snapshot is fully pulled on from into the EBS volume. So you know that the volume is ready to take production traffic. That's available for all volume types, not just in the context of this feature. So volume initialization is one of our basic workflows. If you think about army launches, right, it triggers the volume initialization workflow. And we have seen customers who have a single army launching hundreds of instances use this feature because it gives them predictability that all those instances are ready to take on workload production traffic. We see customers who are copying environments across AZs because the copy volume is an in-AZ copy of the volume. If you're copying volume production environments across AZs, this is again useful to make it predictable and fast. And lastly, if you are recovering from a disaster, you're recovering from a snapshot to a volume, you have strict RTOs, recovery time objectives. This ensures that you are able to meet that recovery point objective. So it's a core primitive for us, and we're going to invest in that to make it faster. So it speeds up a lot of workflows. Just summarizing all the things we spoke about here. So Aaron spoke about the real-time transaction system, extremely latency sensitive. So we reduced the IO2 BX volume latency definition from sub-millisecond to sub-500 microseconds. So you can handle even stricter latency guidance. To make sure that all your customers can benefit from this latency, we have IO2 worldwide available. So you can have the same stack across the whole world. We launched metrics, performance exceeded checks. So volume exceeded checks we launched last year, and instance exceeded check we launched this year. So in a stack, it's very easy to figure out if the bottleneck is the instance or is the volume. We launched average latency metrics last year, average IOPS and throughput this year. So you can trend your performance over a period of time, put in alarms, and figure out when something is going wrong. On the resiliency side, we talked about latency injection with FIS, fault injection simulator. We had launched pausing IO in 2023. That basically simulates, hey, if you have timeouts in your stack, how does it propagate from the storage rate upwards? If you have certain alarms, how does that propagate? In this year, we launched the ability to inject latency into your data path, right? And we have 4 templates, but you can also create your own template with read-write mixes and how much microseconds of latency you want on the read part or on the write part. And lastly, customers accidentally delete data, delete a volume, delete a snapshot. We had recycle bin protection for snapshots. We extended that to volumes as well. On the analytical warehouse system, you need a lot of speed to pull data from S3 into the EBS fleet. So we have larger and faster single volume GP3 volumes, R8GB with 150 Gbps of bandwidth and 720K IOPS. As I mentioned, also helps your OLTP systems. The larger and faster GP3 makes test dev environments much more simpler to use, and the R8GB enables you to land even larger and larger workloads on top of EBS. And for dev environments, for developer environment to improve developer agility, we launched volume clones. You can instantly create a performant volume from another EBS volume in the same AZ. Provision rate for initialization and time-based army copy makes having a golden image and copying it across the globe much more easier. Initialization status helps you understand when your volume is fully ready, and you can put that in production to take on latency-sensitive applications. So that's the bunch of features we launched this year. These are the other EBS sessions if you are interested in. The last one is about networking and EBS workloads. If you like Darren, he will be there for that session, so you can go for that one. And then Adam and I will be hanging out here, so if you have any questions, let us know. Please take the survey. We read all the surveys. If you can put notes in there, that's great, because we look at that and figure out how to make the session better next year. But thanks for coming. I know it's a very late session, so we appreciate you all being here. Thank you.